To calculate the previous question's answer, instead of the flat surface, we need to do on the inclined surface. So this is inclined surface of the theta, and this is slide 3, slide 2, slide 1, and this is connected by rope, and this T tension is pulling over there. So, and obviously, first of all, we need to draw the. This is third slide 3, second 1, and mass is M3, M2, M1. So M3, M2, and M1. And obviously, over there is a different scenario. Obviously, there will be T3 over there, and T3 for this one is opposite direction, T2 over there, and T1 or just T, and mg force will be over there in this direction, and this angle will be also theta, so mg cos theta in this direction, normal over there, and same for this one, mg cos theta normal, and mg will be this direction, mg in this direction, mg cos theta normal, and there will be in this direction one more force, which is mg sin theta for the every block over there. So for the block one, we can say that net force is equals to m1 a1 in the, or let me write it better, sigma in the fx direction is nothing but m1 a1x on the first block. So, and that is just and f applied and minus of, I think f applied minus of t1 would be over there. So yeah, t1 or second slate t1 t2 t2, so yeah, so that will be just net force will be F, which is applied over there, and that we have represented by T. So just let's say T is just F for the better convenience, minus of the T2 over there, and that minus of M1 G sin theta as well in the downward direction is equals to nothing but just M1 A1X. And same for the second one, net force Fx for the second is equal to M2 into A2X. And obviously over there A1, A2 and A3 is the same for all of them because they are connected by the frictionless and massless rope. So we gonna not use A1 or A2 over there, just AX. So net force over there for the second block would be just T2, T2, yeah, T2 minus of T3 minus of M2G sine theta, which is equals to M2AX. And for the third one, again the expression comes out to be, I think, T3 minus of M3 G sine theta equals to M3AX. So now we can say that when we adding all these three equations over there, this equation is third equation, second equation, this is third equation, second equation, and the first equation over there. So when we add all of these, this basically comes out to be F minus of T2 minus of M1 G sine theta. Yeah, F minus of over there, this equation is F minus of T2 minus M1 G sine theta, and plus of T2 minus T3 minus M2 G sine theta plus of T3 minus of M3 G sine theta, which is equals to just AX into sigma M, which is M1 plus M2 plus M3. So T2, T2, T3, T3 get cancelled over there. So F minus of M1 G sine theta, M2 G sine theta, and M3 G sine theta will remain over there. Or let's say G sine theta comes out, sigma M, which is M1 plus M2, which is equals to AX into sigma M, which is M1 plus M2 plus M3. So AX over there, that comes out to be F minus G sine theta into M1 plus M2 plus M3, and upon sigma M M1 plus M2 plus M3. And that means AX over there, when we divide one more aspect, F upon sigma M, which is M1 plus M2 plus M3 minus of G sine theta, will be come out because this and this get cancelled over there. So x will be this much.